Good evening and welcome. My name is Andrea Locke and I am the coordinator for the Western New York Partnership for Regional Invasive Species Management. I'm very excited to provide this presentation on the relationship between invasive species, pollinators, and restoration as part of the New York Invasive Species Awareness Week. We are celebrating the 8th annual New York ISAW with events and activities taking place throughout the week across the region. Please take a look at our website and events calendar to learn more about the events taking place in Western New York, and check out nysaw.org to find events in other regions across the state. I am the coordinator for Western New York PRISM, one of 8 regional partnerships in New York State. Established in 2014, the Western New York PRISM region includes the 8 westernmost counties. Our mission is to address invasive species priorities through the use of a strong partnership network to improve, restore, and protect local aquatic and terrestrial resources. We've worked with over 200 partner organizations, including state and federal agencies, businesses, local municipalities, nonprofits, researchers, and individual community members. We coordinate many programs that involve education and outreach, prevention, invasive species removal, and restoration. If you want to learn more about our initiatives and see how you can get involved, head on over to our website, westernnewyorkprism.org. I always like to start discussions with the definition of an invasive species. I feel that it's important that we're on the same page because there is often a misunderstanding of the term. An invasive species is one that is non-native to the ecosystem under consideration and whose introduction causes or is likely to cause economic or environmental harm or harm to human health. And that harm, whether economic, environmental, or health related, should be observable and measurable. So we aren't talking about weeds, which are basically plants that anyone doesn't like for any reason at any given time. And we aren't talking about exotic or even non-native species. Most exotic, meaning from far away, such as another continent, and non-native species, which is determined by habitat type as well as geography, pose no threat of harm. So it comes down to a species being both non-native and causing harm. I'm not going to get too into the direct economic and human health impacts of invasive species today, although 30 minutes from now, you'll probably have figured out how some of the environmental impacts we'll be talking about relate to pollinators or relative to pollinators do in fact lead to economic and human health harm. So what I will talk about are the environmental impacts of invasive species. Invasive species cause the loss of biodiversity and structural diversity and contribute to habitat degradation and destruction. Biodiversity is a concept I believe most people understand, referring to the number of unique species present within a system. Structural diversity, however, is something I feel is too often overlooked. This refers to the vertical structure of root systems below ground, having herbaceous plants, shrubs, and trees. It also refers to the spatial structure, the amount of canopy cover, total cover, and the cover within the different levels, such as the shrub layer or the small trees. Invasive species also contribute to the disruption of natural processes and ecosystem services, which basically refers to how an ecosystem functions and the benefits that we get from that functional ecosystem, things like clean air, water, and soil. Invasive species do contribute to lower water and air quality. They alter nutrient cycling and nutrient loading in water bodies. They disrupt how and where water moves across the landscape, and they contribute to erosion. Our native plant communities have deep and elaborate root systems that, among other things, hold the soil together. While many of our invasive species have shallower roots, this is evident along stream banks or ditches where you may have a significant reed canary grass infestation. The water basically undercuts the bank and then the edge eventually collapses in. And of course, while we're here today, invasive species do negatively impact pollinators. The photos here show Japanese stiltgrass, knotweed, and narrow-leaved cattails. These near monocultures of invasive species have become all too common. Here we have reed canary grass, an understory of honeysuckle, Phragmites along the highway, and water chestnut. These altered habitats are unable to support our native insect, bird, and mammal populations. It's devastating to our native diversity, and it provides minimal habitat, including limited forage and shelter for native species. Healthy plant communities, or healthy native plant communities, not only provide the necessary habitat conditions for our native fauna, They provide resilience against the disruption of those ecosystem functions. So rather than these altered habitats, we look at healthy native plant communities. Diversity, both in terms of the number and composition of the species and in the spatial structure of how these species coexist and interact, provide resilience against the disruption of these ecosystem functions, and it is essential to maintaining insect pollinator populations. Diversity sustains us, whether you're interested in resource for economic reasons or in the aesthetic value of a diverse landscape. We can't ignore that diversity is necessary for us as humans to survive. We can think of an ecosystem kind of like a game of Jenga. The first few pieces that you take out don't necessarily impact the whole. It's resilient. It can withstand the pressures and disturbance and loss of some species. But the more species and the more pieces that you take out, the less stable it becomes. And you don't always know what piece is going to result in the tower falling down. And while invasive species can appear like they are filling in for some of those other missing native pieces, they're more like the empty spaces, contributing very little in the way of support and eventually causing the collapse, making it even more surprising when it happens because you actually think that some of those spaces are being filled. This is the invasion curve. It's an exponential curve that shows the basic trajectory of an invasive species once it arrives in an area. When invasive species is introduced and begins to establish and spread, it can very quickly move up along the curve. As more acres are infested, the greater the negative impacts are felt. A couple of common buckthorn shrubs, a couple of individuals aren't really a big deal. Even though common buckthorn is an invasive species, if you have only a couple, it's just another species in the woodland. But as it spreads and supplants and outcompetes the native species, you start to see a lot of those significant impacts. The ideal time for intervention for management of invasive species is when the species is low on the invasion curve. This gives us the best shot at eradication or the very least containment. Here we have the most tools at our disposal and the highest likelihood of success. But as we move along the curve, our management becomes more difficult. Our options or tools decrease and it gets more expensive. And we're also looking at a much longer time investment as we move along the curve. Unfortunately, widespread public awareness of an invasive species doesn't typically happen until we are well beyond the ideal window for intervention. You can see the red arrow there on the curve, where is kind of the typical widespread awareness time. And this doesn't mean that we can't do anything, but it does mean that it's a shift in strategy as to how we are managing for invasive species. We often call this strategy asset-based management, meaning we're either managing something other than the invasive species or we're trying to keep a particular species out of a high priority area. Habitat restoration can fit into this category. The goal is the restoration of a native plant community, while invasive species management is more of a strategy to help meet that goal. It isn't like early detection, rapid response, where the goal is just to get rid of the species, no matter where it is. And much of Western Europe PRISM's outreach programming is actually aimed at moving that arrow down the curve, teaching people about the less common species that we need to address before they become the next Phragmites or knotweed. Many, if not most, of our terrestrial invasive species were first introduced through the nursery and landscape trades, and that's not really a huge surprise. For our urban and suburban landscape, most folks are really looking for easy. And this led to nurseries favoring species with a particular set of characteristics or adaptations. Characteristics such as a species that grows in variable soils. So whether you have sand or clay, this one will work for you. Species with both shade and sun tolerance is also preferred because you often will have shade in the morning and sun in the afternoon, or the other way around. Also, species that thrive in a range of climates are favorable, ones that can be sold up and down the East Coast. And perhaps the most important to homeowners, species that require minimal maintenance and are pest-free. Most people want their gardens to be filled with plants that haven't been chewed up by insects or deer. But of course, that means that our pollinators don't have anything to eat either. So an interesting kind of relationship here, when you add in prolific seeding and easily spread to this list of characteristics, you pretty much have a list of the common denominators of invasive plant species. As we begin to consider pollinators, the first thing we recognize is while in popular media and discussions about pollinators, they tend to revolve around bees and butterflies, mostly honeybees and monarch butterflies. But the story is so much bigger and more complex than that. And while honeybees are wonderful, and I love honey, they're actually non-native. So while what I'm going to talk about isn't specific to honeybees, there are still a lot of connections to the relationship between invasive species and native species. While pollinators do come in many shapes and sizes, including birds, bats, and small mammals, I will be focused mostly on insect pollinators. However, since birds, bats, and small mammals rely on insects as food, there's still a really good connection there as well. And then another connection is that native species each require a specific set of habitat components to support them through their life or life cycles. Butterflies need some plants for nectar, but caterpillars need different plants to eat. It isn't enough to plant flowers. We need to address host plants and plants for forage. Without habitat throughout the year or life cycle of any particular species, it doesn't really matter if we have that wild columbine or swamp milkweed, both pictured here with the hummingbird and butterfly respectively. So pollination, it is an essential ecosystem service. It is an ecosystem service that maintains all life on Earth. Pollinators carry that heavy burden of ensuring that plants are able to reproduce. I'm not suggesting that all plants require insect associates to reproduce. Some use other methods, such as wind, to do this. But most do depend on pollinators, from trees to sedges. And these plants are the basis for many of the natural resources on which we as humans depend, not least of which is our food, but even those who don't like to eat their vegetables are eating grains, fruit, and meat. And remember that cows and chickens also depend on plants. So basically, invasive species bad, pollinators good. But how exactly do invasive species impact pollinators? Invasive species impact diversity, and pollinators need diversity. But that's still pretty general. So we want to look a little deeper at why we are so concerned about the decline of pollinators. And here I have listed the 4 leading causes of pollinator decline: habitat loss, degradation, and fragmentation, invasive species, non-native species, and disease, pollution, including pesticides, and climate change. Separating and highlighting the first 2 from the second 2 wasn't just a stylistic formatting choice. It's because habitat loss, degradation, and fragmentation and invasive species are far and away the leading causes of pollinator decline. Pesticides and climate change absolutely contribute, and I will talk about pesticides a little later on. But when discussing the root cause of pollinator decline, we have to start at the top with the habitat loss and invasive species. So habitat loss and fragmentation is a landscape problem. It's an urban-suburban problem, a rural problem, a green space problem, a natural areas problem. It's an ecosystem problem. Human activities, human development has resulted in the significant loss of habitat for pollinators and all of our native species. 52% of land has been urbanized. 43% is in agricultural production. And we have over 4 million miles of paved roads in the United States. Only an estimated 3 to 5% of land in the US is undisturbed. And this doesn't necessarily offer an assumption of quality, and that's where the continued degradation comes in. Furthermore, in the US, over 70% of our eastern forests are gone, and less than 1% of our prairies remain. To give this in perspective, as of 2020, just under 20% of the Amazon has been logged. That means that 80% of the Amazon still remains. And we have 1% of our prairies remaining. The United States is home to some of the most threatened and endangered ecosystems in the world. And we can't depend on the remaining 3 to 5% of undisturbed habitat to fully support pollinators. Research has shown a roughly 1-to-1 loss. This means that 70% loss in habitat is roughly equal to a 70% loss in pollinators. This means that we've already lost over 90% of our pollinators. We also need to keep in mind that the 3 to 5% is not all in one place. It's fragmented, scattered across the landscape, and under continued threat of degradation. Now, degradation is the slow loss of high quality habitat, usually due to continual disturbance or human input. Natural areas and nature preserves feel this constant pressure from the outside and that boundary between the preserve and the human landscape. The smaller the preserve, the more quickly it will succumb to that pressure or degradation. And we also know that this is where invasive species take hold. Along property boundaries, trails, and streams, invasive species use these pathways of invasion to move into natural areas, establish, and spread. And this leads us to how invasive species contribute to pollinator decline. So it isn't abstract or general. Invasive species presence has a direct impact on insects, both in the number of species, the biodiversity, and the number of individuals, which I will refer to as biomass. Native plant communities produce over 4 times more insect biomass than communities dominated by invasive species. Native plant communities support over 3 times as many species than those dominated by invasive species. There is an even greater impact when just considering caterpillars. Native plants support 35 times more caterpillars than invasive plants. And so let's relate this to birds, because I'm a bit of a birder, and 96% of birds depend on insects and spiders and other little critters that most people just refer to as insects. But 96% of birds depend on insects as food. Some birds may at times favor berries. However, your perching birds, gulls, shorebirds, rails, and quail, they all feed on insects and depend on them at least to feed their young. So 35 times fewer caterpillars means 35 times less food for your warblers, for your sparrows. I recognize that fewer insects may sound great to some, but we're not talking about mosquitoes and ticks here. Remember that without insects, a land without insects is a land without most forms of higher life. One of the reasons why pollinators are so dependent on native plants is because most of our native insect pollinators are what we call specialists, and they are unable to survive on non-native species. Specialists rely on species they share an evolutionary history with. And a lot of this actually comes down to leaf chemistry. All of the cool defense mechanisms that plants have come up with limit the number of predators that can safely feed on the plant. So remember that we need plants and habitat to support insect pollinators during every stage of their life. And to be fair, pollen is pretty much pollen. And as long as the insect can fit their little legs in there or other body parts, they can pollinate it. But if we don't have the plants necessary for the caterpillars and larvae and eggs, the pollen, is kind of secondary. 90% of plant-eating insects are going to be, they're specialists. And a specialist insect is one that uses a small range of host plants for one or all of their life stages. Some insects may only use a single species as their host plant. Some examples that you've seen going by on the slide so far are the spring azure here, using Ceanothus or New Jersey tea, and the Carner blue butterfly, which need lupin. The regal fritillary larvae only eat violets, though they also require warm season grasses for cover. And I mentioned that this specificity developed along with plants. And as they adapted, this relationship building, these adaptations, well, they just develop very, very, very slowly. So let's look at that. There are some invasive species that have been in their non-native homes for a while. Phragmites has been in North America for over 100 years. In its native range, 170 insects feed on Phragmites. And after more than a century here, only 5 insects have been identified to feed on it. Clematis, a common landscape plant, supports 40 insect species in its native range. In New Zealand, where it is invasive, only a single species has been found to feed on it. And after 250 years since being introduced to South Africa, no insects have been found to feed on the invasive cactus Theopuntia identified here. The idea that an invasive species can be naturalized, a term sometimes used to identify a non-native species that has become so common in its non-native range that it's just become part of the natural system, that a system is essentially adapted to it and therefore there is no longer any harm, is in conflict with the definition of an invasive species. If a non-native species doesn't cause harm, it's just a non-native species. If a species is not being used by insect pollinators and its presence has resulted in the native species those insects need to no longer be there, it is causing harm. So maybe a dandelion could be considered under this umbrella of naturalized, but not an invasive species. The two definitions they just can't work together. And species just don't adapt that quickly. They don't adapt on a human timescale. And specialist species probably don't have time to adapt before they're lost. But this does bring us to the other side of the coin, and it brings us to generalist species. If 90% of insect pollinators are specialists, what about the other 10%? Well, these are generalists, species that have the ability to feed or use several different plants. These may be plants within the same family, such as the swallowtail example on the slide, or the honeybee that can pollinate just about anything and fit its little feet in. And in general, generalists are more common than specialists. There are a lot more generalists, a lot more of these fewer species than there are numbers of the specialists. So let's say that you're comfortable with losing a large percentage of species. Could the generalists take over? Could the generalists fill that niche and make sure that we still get our tomatoes, our dill, and honey? Well, no. Research has found that native plants and native plant communities still support more than twice the biomass of generalist species when it compares it to communities dominated by invasives. Some research has even shown it as high as 6 times more biomass of generalists being supported by native plants. So it isn't just the specialists that are being harmed by invasive species, it's all of them. Now, I do recognize that generalist pollinators do use invasive species. I have walked by populations of knotweed in bloom and have heard all of the busy little bees swarming around the buffet, but it still isn't equal. Even if your primary concern are honeybees, if you only have knotweed or Canada thistle, what do the bees eat when they aren't flowering? Knotweed flowers late in the season, August or September, and just for a few weeks. Many beekeepers actually need to provide supplemental feeding for their bees because when there are no flowers, they have nothing to eat. So yes, while honeybees and other generalist species will absolutely feed on knotweed, there are far and away better plants and better plant communities to support them throughout their entire life cycle. So this brings us to our last contributor to pollinator decline, and that is, or at least the last one that I'm going to talk about today, and that is pesticides, or more accurately, insecticides. The improper use of insecticides does contribute to the decline of insect pollinators. And improper use includes the misuse, using a product against its labeling, for those of you familiar with pesticide laws and regulations, but also includes the overuse and unnecessary use. There is an objective or measurable way to determine overuse in most cases, but unnecessary use is subjective. I don't think it's necessary to treat our lawns with insecticides. Of course, I don't really value the aesthetic of a perfectly manicured lawn. From an ecology standpoint, lawns are little better than paved roads when it comes to habitat value. And the leading contributors of insecticide use are homeowners with lawns and the business, the municipal ornamental landscape maintenance thing, along with industries, including, but not only, agriculture. The use of insecticides to manage invasive species is very limited, certainly relative to these top contributors. Invasive species managers are also using them to protect pollinators, to protect our native biodiversity, and to improve environmental and human health. And I argue, as I have been over the last half hour, that invasive species management does represent necessary use. And even with invasive species management in this context, we're really primarily talking about herbicides and not insecticides. So what it boils down to is that without the ability to use herbicides, invasive species management and habitat restoration is impossible. Not difficult, it's impossible. Alternative methods of invasive species removal are ineffective against many of our most problematic and well-established species, and more often than not are far more harmful to the environment and human health. Some standard non-chemical management methods include various manual and mechanical removal. Manual removal is great for small isolated populations when you're low on that invasion curve. But when addressing larger infestations, manual removal, if even practical, can lead to significant soil disturbance, which both harm the native plant communities and soil communities and provide really great habitat for more invasive species to just move on in. Mechanical removal can involve mowing, which is actually often used as part of an integrated pest management strategy involving the use of herbicide to manage species. But in and of itself, it also just keeps native plants from flowering alongside the invasive species. And some mechanical removal even involves excavation. If you thought manual removal disturbed the soil, excavation for the purpose of invasive species removal is not good. But when used properly and as part of a well-planned integrated pest management strategy, pesticides can be a safe and effective means for addressing invasive species and restoring our native plant communities. And unfortunately, without them, we're pretty much stuck. So, that's the story. And at this point, the next step is yours. I encourage you to learn about invasive species, learn how to identify them, which are going to pose the most threat to pollinators, and learn how to manage them. I encourage you to support removal efforts. You can volunteer or you can voice your concern to your municipal leaders. You can help stop the spread of invasive species, taking small actions to just clean off your equipment and gear before moving from an infested area into a non-infested one. You can support restoration efforts. Similar to removal, you can volunteer to plant species or, again, talk with your municipal leaders about the importance of restoration and using native plants in municipal gardens and along streets. You can reduce the use of pesticides in your lawns, or better yet, reduce your lawns. And you can plant native. Lots of really cool plants out there. Just don't forget that our pollinators need the sedges and grasses and rushes, right along with all of the beautiful, colorful flowers that we have as native plants here. And here are some of those beautiful native plants. Some nice photos for you to finish up the presentation. If you are interested in adding some native plants to your garden, we have a local native plant suppliers guide on our website. Just head to westernnyprism.org/management, and click on Sources of Native Plants in Western New York. We also have an events calendar where you can find opportunities to learn more about invasive species for sure, and then also to volunteer. And we have a listserv, which you can sign up for on our website if you'd rather not keep checking back at the calendar. I'd also like to plug a couple of books. The first is Bringing Nature Home by Doug Tallamy. This is a great reference for the backyard naturalist or urban gardener. It's also the source of many of the figures I used in the presentation today. And the Birder's Handbook, which has a bunch of authors, but this is a great companion to bird ID guides. It gives you information on habitat and food requirements, as well as a bunch of other little interesting nuggets. And with that, I would like to thank you once again for joining us this evening, and I'm happy to take questions.